Hi, and welcome to Historical Influence. Here, we explore amazing stories of people and events that shaped our history. Join us to learn, discover, and get inspired by the past in a fun and engaging way. Sir Isaac Newton, born in 1643, was an English polymath whose work established classical mechanics and redefined our understanding of the universe. He was a key figure in the 17th century scientific revolution and the subsequent Enlightenment. Though known primarily for his theory on the law of gravity, Newton made seminal contributions across mathematics, physics, and astronomy. While studying at Cambridge, he began formulating theories on light, calculus, and celestial mechanics. His major works, Philosophiae Naturalis Principia Mathematica and Optics, cemented his legacy, making him one of the most influential minds in the history of science. Along with German mathematician Gottfried Wilhelm Leibniz, Newton is also credited with formulating infinitesimal calculus. Isaac Newton was born on January 4, 1643 in Woolsthorpe, England, 3 months after his farmer father died. When he was 3, his mother remarried and left him with his maternal grandmother. This experience later contributed to an acute sense of insecurity. After a failed attempt to turn him into a farmer, he attended the King's School in Grantham before enrolling at Trinity College, Cambridge in 1661. Although Cambridge was steeped in Aristotelian philosophy, Newton was drawn to modern thinkers like René Descartes, keeping extensive outside notes titled Questiones Quaedam Philosophicae. In 1665, the Great Plague caused Cambridge to close. Newton returned home to Woolsthorpe, and this isolation became an extraordinary period of genius. During this 2-year hiatus, he conceived many of his most important insights, including the foundations of his theory of light and color, the laws of planetary motion, and the method of infinitesimal calculus. Historians describe these years as the richest and most productive ever experienced by a scientist.
The legendary story of the falling apple took place during his time isolated at his farm. While observing an apple fall from a tree, Newton wondered why it consistently descended perpendicularly toward the Earth's center. This led him to theorize that the power of gravity extended far beyond the Earth, potentially as high as the Moon, influencing its orbit. English astronomer Edmund Halley later visited the secluded Newton in 1684 and urged him to mathematically organize his findings on the elliptical paths of celestial bodies. The result was the monumental 1687 publication Principia Mathematica, which established the universal laws of motion and the law of universal gravity. Newton's law of universal gravitation states that 2 objects attract each other with a force proportional to their masses and inversely proportional to the square of the distance between their centers. This work provided the quantitative description of bodies in motion and offered explanations for nearly every motion in the universe, including tides and comets.
Newton's early genius also covered optics. From 1670 to 1672, he lectured on the subject. Through painstaking experiments with refraction, he discovered that white light was a composite of all colors on the spectrum. He demonstrated that the multicolored spectrum produced by a prism could be recomposed into white light by a second prism. He asserted that light was composed of particles, or corpuscles, rather than waves. To bypass the problem of chromatic aberration, color dispersion caused by lenses, Newton designed and constructed the first functional reflecting telescope in 1668, today known as the Newtonian telescope. After demonstrating this invention to the Royal Society of London in 1671, he was elected to the Royal Society the following year. His work was later compiled into his second major publication, Optics, released in 1704. This book detailed his experiments and included ruminations on subjects like energy and electricity.
Philosophiae Naturalis Principia Mathematica, published in 1687, has been called the single most influential book on physics and possibly all of science. The Principia achieved the first great unification in physics, establishing classical mechanics. The work presents three fundamental laws of motion. 1. Every object in a state of uniform motion will remain in that state unless an external force acts on it. 2. Force equals mass times acceleration. F equals ma. 3. For every action, there is an equal and opposite reaction. His mathematical description of gravity helped derive Kepler's laws of planetary motion, accounting for tides, comets, and the precession of the equinoxes, thereby eradicating doubt about the heliocentric model. Newton also used the Principia to outline 4 rules for scientific inquiry, which became the basis of the modern scientific method, emphasizing that propositions must be inferred from phenomena and generalized by induction. Though his work provided the foundational structure for the European Enlightenment, Newton warned against viewing the universe as a mere machine. He believed that gravity alone was insufficient to sustain the stable circulating motion of the planets without divine power.
Newton was known for his fierce defense of his work, leading to major disputes. Robert Hooke sharply criticized his initial optical papers. Later, when Newton published Principia, Hooke accused him of plagiarism, claiming priority for the inverse square law, despite lacking the mathematical demonstration Newton provided. A second bitter dispute centered on credit for calculus, which Newton had developed as fluxions in the 1660s. When the dispute with Leibniz erupted publicly, Newton, serving as the president of the Royal Society, starting in 1703, oversaw an investigation that ruled in his own favor. Modern researchers later concluded that both men likely arrived at their theories independently. Newton served as president of the Royal Society until his death. He also served 2 brief terms as a member of Parliament. For his achievements and stature, he was knighted by Queen Anne in 1705.
Newton was a prominent figure in public life, moving permanently to London after being named Warden of the Royal Mint in 1696, and later becoming Master of the Mint in 1699. He treated this position seriously, successfully prosecuting counterfeiters, including William Chaloner. He also reformed the British currency, notably moving the pound sterling from the silver to the gold standard in 1717. In his private life, Newton was an ardent student of history and religious doctrines. Over half of his voluminous writings concerned theology and alchemy. He privately held unorthodox Christian views, rejecting the doctrine of the Trinity, classifying him as an anti-Trinitarian. He dedicated decades to the study of alchemy or chemistry, a fact he kept largely hidden from his contemporaries. John Maynard Keynes famously called Newton the last of the magicians. Some researchers speculate that chronic mercury poisoning resulting from his alchemical pursuits may explain some of his eccentric behavior later in life.
Sir Isaac Newton died in London on March 31, 1727, at the age of 84, and was buried ceremonially in Westminster Abbey, the first scientist interred there. He is remembered as a transformative scholar, inventor, and writer. His contributions were monumental. He founded classical mechanics, developed calculus, eliminated doubts about the heliocentric model, and his methodology gave birth to the modern scientific method. Although his concepts were later superseded by Albert Einstein's theories of relativity, Newton's work remains the bedrock upon which modern physics was built. Einstein stated that Newton's creation of calculus, alongside his laws of motion, was perhaps the greatest advance in thought that a single individual was ever privileged to make. Many contemporaries and later thinkers called him the greatest genius who ever lived. Reflecting on his life, Newton famously wrote, "If I have seen further, it is by standing on the shoulders of giants." His tomb epitaph aptly proclaims him Humani Generis Decus, an ornament of the human race.
Share your thoughts in the comments, and don't forget to subscribe for more stories that shaped our world.